Okay. Yeah, thanks, Animesh. So basically, today's session is about deception. So we'll use deception in the attack chain. Like we'll see how an attacker compromises an environment, and like while going through different phases of an attack chain, like what are the opportunities where we can use deception, and first of all, what is deception and how it can be part of malware defense. So I'll talk on this topic today. A little bit about myself. So I'm working with Hack the Box right now in the defensive training development part. So I've created a lot of defensive modules on Hack the Box Academy and other labs and Sherlock's. And also, I've been working in the industry as a researcher, threat hunter, incident responder, and mostly into defense and red team, blue team research roles. So uh, before we talk about deception, so let's understand like when we talk about malware defense, so what all we have in mind. For example, whenever we have to defend our systems or network from malwares, so how do we design our defense system? How do we create detections for a malware? Yeah, is anyone asking something?
No, not now.
Okay, all okay, everything is visible.
Yes, it's visible now.
Cool. So you can see the photo of Tom and Jerry, which shows it's offense and defense is a cat and mouse game. So whenever attackers evolve with their TTPs or techniques, so defenders also evolve. They also create signatures for that or detections or like behavioral based detections. So when we have to detect a malware, we try to create signatures based on the different artifacts that we get from a malware, such as the strings used. So starting from like very beginning when the malware attack started to evolve initially, so we used to defend using the signatures like strings, like the antivirus tools use the strings and signatures to detect the malware. But malwares over time got very sophisticated. They started to like work on the systems without dropping much evidence. Like they started to operate filelessly. Like let's say they started to operate in memory. So there are very less or no evidence on the system. So because of that, the defense mechanisms also evolved. Like people started to use in-memory detections, like started to use like event logs and using right now using AI to go through a lot of event logs to analyze the data and identify threats inside that. I'll give an example of how Elastic is using the AI, like leveraging the large language models to analyze a lot of alerts. And a second thing, like process context anomalies. This is, for example, let's say a process starts on a system, and then after starting within 5 seconds, let's say it starts to connect to internet, starts to connect to a random domain, unknown domain, or like start to do something on the file system. Let's say it creates a new process, or it creates a thread into a remote process. These kind of things, like that is process context. Also, like what kind of process it is, whether it is allowed to connect to internet or not. For example, notepad.exe is not supposed to connect to internet. It's just a text editor. But if you see in event logs that there is a network connection initiated from notepad.exe to some random domain, so that's an anomaly. So that kind of information comes under the process context. Then parent-child relationship anomalies. These are kind of anomalies, like for example, uh, Microsoft Office Word is spawning a command prompt or PowerShell. So PowerShell is a child of MS Word. So it's a parent-child relationship anomaly. These kind of things are also in place. The antivirus or EDR systems have these kind of checks in place. And then we have behavioral detections. This again checks the behavior of a malware or process running on the system, like whether it does something on a remote process, interacts with the remote process, like do a process injection, creates a remote thread in a remote process, these kind of things. What is the behavior of a process when it runs? And then in memory scanning. So that's also a very important part of the malware defense now. Like whatever is happening in a memory of a process is also scanned, whether there is something malicious inside the process memory or the virtual memory of a process, whether there are some instances of shell code or some malicious piece of code or strings inside the memory, that is also scanned. Then the network telemetry, like if a process is connecting to internet, now at what IP address it is connecting to, what is the reputation of that IP address or domain, these kind of things come under the network detections. Then we also leverage the event logs, ETW telemetry, telemetry from like drivers, like for example the EDR drivers that are installed on the system, and then use of artificial intelligence, like leveraging the large language models to analyze a lot of alerts. And then we also have deception. So our focus of today's talk is on deception. So how it can be used or how it is being used. So first of all, I'll give an example of leveraging LLMs to analyze alerts. So this is a feature in Elastic. So it's called as attack discovery. So you just choose one of the LLM connector, enter your details like the model name, access key, and then you can click on generate button. It will go through all the alerts that it has, and shows you like generates this kind of summary, like this attack happened on this system, and like let's say it created a child process, it opened a suspicious Excel file on the system. So these kind of things are generated using the help of AI. This eventually makes it easy for the SOC analyst or the monitoring team who are going through a lot of alerts to just reduce the alert fatigue. Like apart from going from the alerts themselves, they can also use these kind of features. Like using AI, it reduces the time. And now we'll talk about the deception technology. So what is deception, and like how it can be used as a part of the malware defense? So we use deception basically to detect the uh, threats which are not detected by EDRs. Like let's say EDRs or the antivirus systems, they work on all the defense mechanisms that we discussed till now, like the behavioral detections, signatures, strings, all of that. But if like we want to detect or catch an attacker early in the attack kill chain, like let's say we want to detect them early in the initial access phase, or like in the reconnaissance phase, deception plays a very important role in that. So there are a lot of different deceptive elements which we call as let's say decoys or honeypots or breadcrumbs. There are a lot of names for different elements that we have in deception. For example, decoy users, decoy computers, decoy databases, folders, servers. So what all of these elements do, whenever an attacker let's say scans a network, there are multiple IP addresses or servers inside a network. Let's say there is a SQL server, and attacker finds during the scan that it is running some vulnerable version of a service, and they try to exploit that. So during that process, like we create a similar server like a SQL server which looks like a real, but it is actually a decoy server. So whenever someone interacts with that, we get an alert for that. So these kind of things can be done using decoy servers or any other decoy element. So basically, whenever someone interacts with that, we get an alert, or the SOC team gets an alert. So even before they actually did something, or they encrypted the system, or the post exploitation phase, we caught them initially in the scanning phase. And there are multiple things which we can consider as the deceptive elements, like the fake browser history, credentials. So whenever, let's say, an attacker tries to dump some browser database, and they find some credential or some URL, and the credentials are also there in the database, and they try to open it. So that leads them to some decoy network server, and once they enter the credentials, so the SOC team gets to know that this server, like some attacker is in the system, because their administrators or the normal users will not interact with that decoy network server. So if someone is trying to interact, it definitely means it's an attacker. So there are other things as well. So uh, other thing is malware checks. So there are some pre-infection checks. For example, before a malware or a ransomware infects the system, they might have some infection checks, pre-infection checks, just to know, just to understand whether they are running on some user's actual system or some sandbox. So there are some techniques. Like for example, if we talk about WannaCry, so WannaCry used kill switch domain, like which was a random domain. So it tries to check whether this domain is reachable from the system, because that domain was not existent. It was not there on the internet. So uh, on a real system, it will not be able to connect to that domain. So if it is not able to connect to that domain, then the ransomware infected the system. But if the system was able to reach this domain which was not present, then it means it is definitely a sandbox, because sandbox sends a response for every domain. Like if you are running inet sim, internet simulator, or like some fake DNS, other tools like that. So just to make sure that the malware is not being analyzed or running on a sandbox. So there are some checks. So we will use one of these checks to make one deceptive element today in this talk. So there are some other anti-debug techniques, tricks also, which are used by malwares. So there is a very good blog from Checkpoint Research. You can go to this website, antidebug.checkpoint.com. uh, every element of this, every trick has a very detailed article written, so you can go through that later. So this is the kill switch domain which I was talking about, which was used by WannaCry. So like this random domain.com. So I think all of you might always know, already know that this was then later registered by a security researcher, Marcus Hutchins. So basically, then on all the systems when this domain was reachable, then the ransomware was not infecting these systems. So similarly, it's up to the ransomware developer, or like the ransomware, like how it is checking whether it's running on a real system or a sandbox. So we'll see how we can use these kind of tricks used by ransomware to prevent the infection. So these are some of the stats on the ransomware attacks, like what it means, like how serious it is. Like for example, in the 2024, the average cost of a ransomware recovery was around $2.73 million, and like there were like around 630 incidents, ransomware incidents, impacting just the healthcare worldwide in 2023. So that's why our focus on today's talk is about ransomware infection. So these are two of the attack chains for two ransomware groups, and here's the link from Microsoft blog where I took it. So basically, you can see in all of these there are some techniques, like these are the MITRE techniques, technique IDs. Like T1193 is for spear phishing attachment. You can see there are some similarities in these. For example, credential dumping is similar, like it is also present in the Vadharma attack chain, and also in Ryuk, and also discovery, and then data encryption. So let's see how we can discover different deception opportunities while going through a ransomware infection. So let's start with an environment. Like let's say for this demo, I'm using Havoc C2. It's a open source C2 available on its GitHub repository. You can also try it out. So it has many great features for evasion, as well as like the UI is pretty similar to Cobalt Strike. So you can see in this scenario, it's kind of a assumed breach scenario where we are assuming that we already have the initial access of one machine, like we'll call it victim machine. So we'll try to do the local enumeration on this machine. So we'll be able to see, like let's say, uh, we'll be able to find out the local administrator account and password, and we'll try to see if it still works, because we found it in like one technique called as GPP preferences. So system administrators used to use this GPP preferences technique to like have the same use like local administrator on all the systems, but this was later disabled by Microsoft because they by mistake they like leaked the key on one of the MSDN documentation. So that's why this technique was disabled, but still you can find some traces of uh, these XML files, GPU XML file, which contains the local admin credentials. And if the password is not changed, it's still same, then it's good. Like you can use that to like enumerate the local admin account, or try to find out any files which are of interest. So this is the initial scenario. Like we'll start with local enumeration on the victim machine, and then we'll find out, like in this sysvol there is a XML file which contains the credentials of local admin, and then using that local admin we'll try to do some further local admin enumeration, and like we'll try to see what a local admin can do all the on the system, and then we'll try to move laterally in the environment. So in this we have one deception opportunity, like this GPU XML file, because this file is of interest for attackers. So we can also create one decoy XML file which looks exactly similar to the real one, and we'll enter one fake password in that, fake username password. So like attacker thinks that it's a real username password and they try to log in, and we can see there is a login attempt for this user, so that we are alerted. We can like plan our defenses accordingly. So let's see a demo of this. So we'll start with the local enumeration. We'll use the power views module get GPP password. So it will automatically find out the XML file, try to decrypt the password, and show us the plain text password on the screen. So as you can see, this is the password, super password, and this is the built-in administrator account. So now, like we'll try to log in with this, and we will try to log in on this system whether this password is still working. So like we can see, like this is the name of the like local admin, which is IT admin 1, and the password is super password. So using these credentials we try to log in on the system, and we now this is the second scenario. We log in as IT admin 1 and try to do enumeration as a local administrator. So in the desktop folder we found some folders which had some files like which were taken by IT administrator. These were like notes.txt. So inside that we found that there were two new interns joining in the team, and those interns had the access to some network shares. So on those network shares, like there might be some interesting database backups. So because that is a database backup folder, so we'll see that later. So this is also an deception opportunity. Like if we can create a similar decoy folder, so whenever someone browses to this folder, we'll get an alert. So I'll show an example how this can be set up. So now, like in this scenario, when we find the Sayan and Madhukar, these two new interns joining the team, we find their emails or the names, but we do not know the password. So we'll try to do the password spraying attack, which is pretty common in Active Directory environments. So using a word list, and one of the password works, which is like welcome at the rate 2024. It worked for one of the users, and then we'll log in. So this worked for the user Cyan, so we'll log in as Cyan and try to like access the database backups and see if there is something interesting in that. So let's start with this scenario. So now we logged in as IT admin 1. We will enter a command to do some enumeration on the system as a local admin. So we tried to see what are the different files inside the IT admin's desktop. So we see that there are some backup tools, some IT related tools, PDQ, deploy and all, uh, software study, and there is also one IT onboarding directory, this folder. So we'll browse into that and see what are the files inside that. So there is a file notes.txt. So it looks like these are some notes related to the IT onboarding. So we'll try to cat or print the contents of this notes file. And inside that we can see the IT admin has taken some notes, like these are the new joiners. They are joining in this team, joining date, and to do some task for these users. Inside that we can see we have to provide, like IT administrator has to provide the access on these folders. So that is interesting. Like it's a SQL server, looking at the naming convention RDSE SQL 01 backup, and also like we have the username passwords of these users, these two users. So we'll plan a password spraying attack where we'll have two target users, and we'll provide a word list that we'll use to do the password spraying attack. So in this, you can see like I've already executed the attack and we got the password for Cyan. So let's start do it from the beginning. So we'll interact with the normal user victim, which is a domain user. So we'll start with this PowerShell script, invoke domain password spray. We'll provide the list of two users, users.txt, and the password list, which is the rocku.txt. And then it starts with the top 100 passwords. So there are 1, 2, 3, 4, 5, 6 passwords. Sorry, this is first password. So there are two target users. So we have some gap between the attempts. So if there is some password lockout policy in the domain, so it does not trigger. So it will take some time, and eventually we'll get the password for one of the users, Cyan. So the password is welcome at 2024. So now using this, we'll try to access the network share RDSE SQL 01 backup. So we can see there are multiple files .bak files inside this folder. So these must be the backup files. Uh, so inside of this folder, like backup folder, there was one of the decoy files. So when the user browsed to this folder, so we got a mail. So basically this can be set up using canary tokens. It's also like freely available on the website, canary tokens. So you can use like this technique to add a decoy directory or file in this network share RDSE SQL 01, and whenever someone browses to this location, so you'll get an alert. So how it works is basically it also adds one .ini file in the same directory. So whenever this folder is opened, so ini file contains the desktop configuration. So basically it contains the path of the icon of this folder. So this path is basically set up on this server, canary tokens, one server created just for you. So there is a request to that server for this icon file. So based on that request, they basically send you alert. They know that someone is browsing this folder, which is not supposed to be browsed by normal users. So that was one of the fake folders or decoy folders. So like when this was happening, like in the SIM, you can see a lot of alerts, and like this thing can be detected using the authentication failures. So if there are multiple authentication failures in a very short span of time, so that can lead to detection of the password spraying, or if someone is trying to like add or brute force in the environment. Now we try to enumerate on the same server RDSE SQL 01, like who are the uh, local administrators on this folder. So one is the administrator, which is also domain administrator, but there is also a service account, a SQL service account. So we can target this account because SQL service account is actually a service account. So service accounts are mostly vulnerable to the curve roasting attack. So we'll try to do the curve roasting attack on this user. because we were accessing the network shared using cyan user who is just a domain user, but he did not have the admin access on this server. So now like the attacker's aim is to get inside this server as a local admin or using this SQL Server service account. So let's see what is Kerberos. So before that, let's understand what is how Kerberos works. So it's an authentication mechanism in Active Directory. So let's say we have a client and there is a domain controller. So client sends a authentication request to the domain controller. This request is encrypted using the timestamp, current timestamp of the system, and the NTLM hash of the user. The request is sent to the domain controller. This is also known as ASREC. And in response, the server sends the ASREP, which is authentication service response. So in the response, the controller sends the TGT to the client. Now using this TGT is also called as ticket granting ticket. So using this TGT, the client requests for the uh, TGS, which is the service accounts ticket. Like so, the scenario is like this client wants to access a server like SQL Server, let's say, and for that it requires the TGS. So the domain controller checks if this user is authorized to get this, and it checks other things, and then it sends a TGS of the target server. In this case, this target server is, let's say, the database server or DSC SQL 01. So now if the client is legitimate, it will use this TGS and request, like tries to connect to this SQL server and try to access the database or other resources on the server. So this is how the Kerberos authentication works. But in case of Kerberosing, only the first four steps are used. Like client sends a request for TGT, receives the TGT. Using TGT, client sends a TGS request and gets the TGS, which is encrypted with the target service hash. So it means like target service is the SQL service account which was running on the this SQL server. So this TGS is encrypted using the SQL server's service account, the hash of that. So if that is if we try to uh, decrypt this offline, we have the TGS now. We'll try to decrypt it offline and try to see like whether we can get a plain text password. So to do that, we have multiple tools, but we'll use a tool called as Rubius. So first, let's try to do uh, curve roasting attack. But before that, I'll just explain the scenario. So we'll log into RD-SQL 01 as a Cyan because he has the access on that, but not the admin access. So after enumeration, it is noticed that this account does not have the admin privileges, and there are two more accounts, which was a SQL service account and the administrator, which is domain admin. So then we targeted SVC SQL service account using the curve roasting, and then we'll access the database, and then we'll do the ransomware attack. So these are the opportunities. Like when we do ransomware attack, we can create decoy mutex. I will explain in detail what is decoy mutex and how we can create it. And let's start with the curve roasting. So we'll just run Rubius. We have Rubius in this attack machine. So we'll just use the .NET inline execute option to execute the rubius.exe on the victim machine. So we'll start with like use a cyan .NET inline execute, then temp rubius.exe and curve roast. Simple. So it will like automatically find out whether there is some curve roasting account, curve roastable account, and it found out that this is one of the accounts, like SQL service account, and then it tries to find out its ticket and prints it on the screen. So we'll just copy this ticket, and using tools like hashcat, we can like try to decrypt it. So this is the thing that we require, like KRB5TGS SQL service account, and this is the ticket. So we'll just copy it and save inside a text file, hash SQL.txt, and then we'll use hashcat to crack it. So we can see that it is cracked and the password is password at the rate 123. For the demo, I kept it simple. So now we have the password to the service account. So we have the service account and its password. Using that, we log in on the SQL server. So let's try to get a RDP on this system. So from Cobalt Strike or Havoc C2 or any other C2, you can use SOX proxy to like run some other program on this system. Like for example, I want to access port 3389 on the remote system. So using proxy chains, I access that using X-Free RDP. It's a tool like available on Linux. You can also download it if it is not available. So using apt, you can install it. So using free X-Free RDP, I try to take access of this user SQL service account and password at 123, because X-Free RDP has this option dynamic resolution. So it's good like if you try to like change the resolution of screen or try to full make it full screen, it works pretty well. So that's why I use X-Free RDP. Otherwise you can use other tools as well for RDP. So let's try to get a RDP session. First of all, like we'll try to add the proxy chains. Inside that we'll add port 9050. I already did that. So now we'll run this proxy chains command with X-Free RDP. Yeah, there's also one thing. So whenever using any C2, you try to take RDP using proxy chains, you need to keep the sleep and jitter 0, 0. Otherwise, the RDP session will be very lagging. So it has to be 0, 0. But at the same time, it is very laggy as well. Sorry, it is very noisy as well. There are a lot of connections going on, like when RDP session is working. So at the network level, if there is AI or some network intrusion detection tools, they can detect this kind of activity. So now let's say we have the access of this system using the proxy chains. So we want to like run a ransomware on this. So we'll try with WannaCry just to explain the concept of the decoy mutex. So we'll just like run a WannaCry on this system just to show this demo. So I've already executed WannaCry and it will try to change the extensions of the files, and then it will install a service on the system. And then once all the files are encrypted, it will like add this banner, change the wallpaper, add a registry key. At the same time, it also adds something called as mutex. So when this was happening, Elastic was also running. Elastic agent was running on the system. So it also detected that there was a malware detection alert. First time seen driver is loaded. So there are some detections. So when malware like ransomware was executed on the system, in case of WannaCry, it creates a process, child process called as task sche.exe, which is the main ransomware program, which has the ransomware module. So inside that, we can see there are three mutants. So where we can see it, I opened Process Hacker. It's a tool available in Windows, just like Process Explorer. So using that, you can open any process properties like task.sche.exe. So go to handles. Inside that, look for handles of type mutant. So these are added by the ransomware. Many ransomwares use these mutants. So basically, what is mutant? So mutex is basically a way used by a ransomware to mark the infection. So it's kind of an infection marker. So this is done in order to avoid reinfecting a system. So whenever a malware infects a system, after infecting, it adds a mutex on the system, and then next time when the same malware is like executed on the system, it checks first whether this mutex is present or not. If the mutex is present on the system, then it will not infect the system again. If the mutex is not present, then it means it's a clean system, so it will infect the system. So this is why ransomware adds the infection marker as mutex. So there are other ways also to add an infection marking on a system, but this is also one of the ways. And ransomwares like Blackbuster, Black Matter, or WannaCry, so they used this. So this is also one of the examples from CISA. Like they have added a advisory for Lockbit 3 ransomware, which also creates the mutex, but this is a dynamic mutex. It's not a hard coded value of a mutex. Like they created global. So basically, global shows that this mutex is a global object, so any program can access it. So then there is a MD4 hash of the machine GUID. So this will be different on every other machine. So if you see this value of the mutant created by the WannaCry, this value is different. Like this value is hard coded. MS Win Zones Cache Counter Mutex A. This is same across all the machines. Like if we like add, if we see like this mutant present on a system, then it means like this is infected by WannaCry. So this is hard coded value, but in case of Lockbit, it is not hard coded. It is a dynamic value. So it checks for the machine GUID first and then creates it. So I'll explain it in detail with the demo. So don't worry. So what is mutex? First of all, I'll show a demo. So this is actually a concept used by system programmers who like want to make sure that there is only one instance of a program running on a system. For example, Windows Media Player, it also uses this concept. So as you can see, mutant check for other instance mutex is there, created by the Windows Media Player. So when this mutant is present, you cannot create a new instance of this program. I'll show an example. For example, there is already one media player running and you try to open other one. It will not allow you to open it. And this is because of this mutant present. So I opened Windows Media Player in Process Hacker, its properties, go to its handles and look for mutant. You can see there is a mutant with the name check for other instance mutex. It is present, that's why it is not opening other instance. So what if we close this muted? So when this is closed, now if we try to again open Windows Media Player, so it allows you to open. So it was not allowing you to open because of that mutex. So similarly, the same thing if we do with Notepad, there is one instance running, we can open the other instance. There is no restriction because Notepad allows you to create multiple instances. But if we do the same thing with Windows Media Player, now one instance is running, and if we try to open other instance, it it does not allow. So it's not working. It's not allowing you to open. So the rest of the things I already explained, like go to properties, check handles. There is a check for other instance mutex present. So because of that, it was not allowing. Then we closed that mutex, so it allowed us. So similarly, the same process is used by ransomwares. So I tried to debug the WannaCry, and you can see there is a call to create mutex A function. So this function is used to open or create a new mutex on the system. So this is the function or Windows API function used by the malwares to create a mutex. So what if we also try to create the same mutex on a system? So in this slide, I have written like how we can check for mutex handles. Like this is also a tool handles by sysinternals, or tools like Process Explorer or Process Hacker can also like help you to open this, open or list the handles of type mutant. We can also search for mutex names when analyzing a memory of a compromised system using tools like Volatility. Volatility also has a plugin to check for mutex or handles. So what if we create a same mutex with the same name on a system as a global object? Then what can happen? So there is a possibility, like for example, I've created a program decoy mutex.exe. What it does, it adds these global mutex objects using the same function, create mutex A. So using this function, it adds these hard coded values. So just for experiment, so we have added all of these as a global object on the system. So how we got these names? So basically we can reverse engineer a malware or ransomware and try to see if it is using create mutex A or trying to create a mutex on the system, and what is the name of the mutex, whether it is a hard coded mutex or it is trying to generate it on the runtime on a system like dynamically, just like Lockbit. So that we need to figure out. So there is also one of the GitHub repositories that maintains a list of the mutex names like this, github.com albert this malware mutex. So from this we got the list of mutex names and we added it as a global object on the system. So now next time when ransomware is executed on the system, it will check whether mutex is present on the system. If it is present, then it will not infect the system. It will assume that it is already infected, and after infection the mutex was added. But it was not added by the ransomware after infection, it was added by us, just as a deception technique. So if the mutex is found, then it will not infect the system. If it is not found, then it will infect the system. So let's see a demo. Now we'll run the ransomware after we run the decoy mutex. So this is the same screen. So first we run the decoy mutex. So if you go to help, you can see we need to provide the JSON with the ransomware name and the mutex names. So just like that, I added some of the mutex names. So I provided path of the JSON file. So inside that there are few mutex objects which are added at the global objects, and WannaCry is also there. So if we go to decoy mutex handles, so we can see it has added all of these on the system. Actually, we should run it as administrator just to make sure that it adds it on the global level so that all users can access it. And once that is done, we try to run the ransomware again. This time it will not infect the system. It will just look for mutex before infection. It will find the mutex on the system, and then it will not infect the system. And after some time, it will, like, this process will be killed. Task SCHE was created and killed. This is like what happens after we add the mutex names by ourselves on the system. So this is an example of the other ransomware black matter, which also checks for this. So you can see it checks if the mutex is present on the system. If there is an instance, then it will not create infect the system. If mutex is not present, then it will create a mutex, infect the system. So how does it create the mutex? It creates it using generate mutex from the GUID. So first of all, it gets a GUID of the system. So this is code for that. So if you see, like, first of all, it gets the machine GUID. After the machine GUID is there, then it tries to like encode that using MD4. It creates a MD4 hash of the machine GUID, and then it uses the create mutex function to create a mutex for that. So if we have to create a mutex dynamically, we can also use the same logic used by ransomware. We can also create a mutant name by doing a MD4 hash of the machine GUID on our system and try to add it as a global object. So that also is the same thing. If that is present, then even that ransomware will not be able to infect the system. But this technique only works for those ransomwares for which you already have the intelligence, or you already have a list of the known mutex that are used by those ransomwares. It does not work for the new ransomware for which you are not aware. So there are some other deceptive elements as well, like for example the decoy users and decoy computers, decoy groups. So this is an example of how you can create a decoy user in Active Directory. First of all, you just create a new user, go to the auditing, go to the security properties of that, go to auditing and add auditing for everyone, read all properties. So what it means, it means like whenever someone tries to do LDAP enumeration or tries to run, let's say, bloodhounds or collector sharphound on the system, so whenever they try to read the properties of all the users computers, everything, they'll also read the properties of this user that we created, which is the decoy user. And once the properties are read by someone, we get an alert because we have done auditing on that, and we have to enable the auditing uh, event logs as well. So that will alert us that someone is trying to read the properties of this user. So this is only possible when someone actually scans the whole LDAP, like scans the whole Active Directory environment using LDAP or other means. So there is a detailed blog that I've written on this. Here's the link for that. So you can read how you can create different decoy objects, like not just the computer. And also as a red teamer, you can use this tool to spot the decoys. This is a PowerShell script, invoke honeypot buster. It's also available on its GitHub. So when you run that on an environment, it shows you like these are the target system, object or computer, whatever, and this is the fake rank. So it actually has some logic to check how what is the properties of this system, whether it's a fake system or fake user or not. So I checked the source code of that. So basically it checks for few things like for example, it checks the object's properties, checks for last logon timestamp. If it is not there, then it means it's a fake object, because if it is a real user, it will definitely log in on the system. So if there is nothing in the login field, then it means it's a fake. Here's an example. For example, this is a real computer, and you can see the last logon timestamp is there, last logon is there, but this is a decoy computer, and you can see these fields are empty. So these kind of tools, honeypot busters, they check for these kind of attributes in the Active Directory, and based on that they determine whether this object is fake or real. So we can like also as a deception engineer or as a defensive person, you can try to set these values so that you again try to make sure that you bypass these kind of tools. And here are some other deception strategies. Like first of all, enable the auditing in Windows. Like this can be enabled using audit .exe. And then you can add fake browser history, fake browser credentials, PowerShell history, because attackers try to go through the console history or PowerShell history files, transcript files, just to see if there are any credentials. So if you inject your credentials in these history files, that will lead the attackers to interacting with these credentials, and then you'll get an alert. So there are already some open source solutions as well as the commercial solutions which deal with deception, so which does all of this. So yeah, that was the agenda of today's talk, like how just to show how we can use deception. So I'm done. If you have any questions, just let me know.
Any questions, anyone? No? Okay.
So, hi. Uh,
Yeah, hi
Great talk,
Karthik.
Madhukar. Yeah. So I had a question. It's mainly related to the RDP side that you talked about.
Yeah.
So you said that RDP is a very noisy process to run, right? It will initiate a lot of network requests and things like that. But recently
Mm-hmm.
there have been a lot of cases of usage of RMM tools,
Mm-hmm. Yeah.
which pretty much do the same thing, right? I'm not sure.
Yeah.
So I wanted to understand why RMM tools have like cyber criminals have started using those compared to RDP.
Hmm.
Are they not
Yeah.
noisy or something like that?
Yeah. So definitely they are also noisy. They use the same science behind that. They also use the same protocols, and at the
PNC.
network level, yeah, they have the same kind of noise. But the only difference is that the detection rules and the strategies are not like created for that, like for every organization. For example, if your organization is using, let's say, AnyDesk or TeamViewer Enterprise, actually for administration purposes, and the attacker figures out that this tool is being used by this organization, and like there are less chances of the detection rules for this tool. So
Mhm.
if they take RDP of that using this particular tool, then there will be a noise in the network level, but that will be ignored. or mostly like the action will be taken later when they detect something else also. But yeah, that will basically generate the same kind of noise, but there will be many things which are different. For example, let's say you are using Havoc C2 or Cobalt Strike, then you have to set up your domains also, right, where the traffic will go. And apart as compared to the domains used by AnyDesk or TeamViewer or any other RMM tools, those domains are standard domains used by those organizations. But in your case, that will be a new domain set up by you as a red teamer, or like some new domain. So there are some comparisons. So these kind of things are detected easily. But RMM tools are also like, if these tools are there are some detections. For example, people, if you see the open source Sigma rules and detection rules created by Chronicle or Microsoft Sentinel, so they have the rules for known RMM tools which were used by attackers.
Okay, thanks.
Yeah, no worries.
Karthikeya, you can unmute yourself. I gave you the permission. If you have questions.
Hello, am I audible?
Yes, you are.
Yeah.
Sir, I have two questions actually. So you just explained the run once mutex concept. So
Yeah.
in that thing, like if the create mutex flag is already set to one, then the function should exit itself at that moment only. So why
Yeah.
it's checking the another instance of it? Like
So yeah, so basically, if there is already an instance of this mutex on the system, then basically it will not infect the system.
okay, so if like for example in the code itself, the create mutex flag set to one only when the mutex is created, or is it have to check the another instance of it also? Like I've seen the code before, because they also an if statement in the if statement after the create mutex flag, and at
Okay.
that moment of time it will exit the command,
Hmm.
not before. Yeah, this one. So
Yeah.
yeah, the create mutex flag should be one, so that it will go inside the if statement and it will create the name and the handle, and then it will check the handle. So what is the significance of the create mutex flag here? Like if it had to check the handle, then it should be on the top before the create mutex flag, or like
Yes.
maybe
So basically, over here in the create mutex flag, so before it is infecting the system, it is creating a mutex on the system. So this function create mutex, it can also open the mutex or also create the mutex. It does both the things. So for it, they are creating the mutex also with the same function, same Windows API, and they open the like already existing mutex with the same function. So basically, they are checking if it is one. It means if it is already there, if it's already present, and then it will like not infect the system. It thinks like there is already one instance running of this mutex with this name, then it will not create a new one.
okay, sir.
And if you see if this, it means like this means if this is present, or this means zero or success, then it will generate a new name. It did not find the already created mutex on the system, so it generates a new one.
Okay, so for here the create mutex flag should be zero to get into if statements.
Yeah, zero means success, that this flag is not there, then it will create a new one. Then it will generate a new one, and using create mutex, it creates a new one.
Okay, okay, sir. Okay,
Yeah, but if it is not zero, it is one means false, then it's already present, then it will not create a new one.
okay, okay, sir.
Yeah, yeah.
And so I have the second question, like you
Hmm.
also should execute the script honeypot buster. So like
Yeah.
that can give us the details of all the honeypots, but isn't it also very noisy to, because it will somehow try to connect to all those fake accounts or computers
Yes,
through this
exactly.
script. So
Yeah,
like
exactly.
what's the purpose of this if we really want to be sure not to use the honeypot?
Yeah, so basically, so I used to work with the one of the deception companies, Smokescreen, which was acquired by Zscaler. So like basically, I saw like in almost all the customers where we use like honeypot, like the decoys or deception technology. So basically, there are some rules that we need to whitelist for our EDRs or other detection controls. So one of those tools are honeypot buster as well. So basically, because this tool is actually used by red teamers, so if someone is running, there are detections for that. But if we are using it to create the detections or just to test our detection controls, then we should whitelist it or ignore that alert. Like there are some uh, whitelisting of the this and other tools also.
Moderation.
Yeah, is it?
Hi, Madhukar. Nice talk. I guess
Yeah, thanks. Yeah.
you answered pretty
Thank you,
much
sir.
all the questions. Thank you,
Thank you, sir.
Karthikeyan.
Thank you. Thank you, sir.
Thank
Yeah, no
you.
worries. All right. Yeah, welcome everyone.
Mhm. Okay, so I guess you guys have any questions?
No.
No. So room is clean. So thank you again for the talk, and I hope to see you again on this platform.
Yeah, sure, sure. Same here. Thank you,
Yes.
everyone.
So
Yeah.
thank you. Okay, so we're planning the next talk on September, I guess July. So
Okay.
we'll update you.
Yeah, sure, sure.
इतने पैसे
Can you ask him,
Yes.
Madhukar, are you using the hack the box labs for your labs, or like is it a local one that you have set up?